Hello and welcome to another video from the Avnet Services DevOps Practice Team. My name is Dan Zenkraff. I'm the DevOps Practice Lead, and today we're going to be talking about the IBM UrbanCode Deploy tool and how it handles process flow logic. IBM UrbanCode Deploy is a process automation engine and has sophisticated tools that allow you to build very complex processes within the tool, but in order to do so you must understand the constructs that exist within the tool. Once you do, you will be able to build those complex flows and also make them much more resilient and robust as you scale through your organization. Okay, so before we get into looking at the conditional logic in the UrbanCode tool set, UrbanCode Deploy tool, what we want to do is take a quick look at what we've got set up. For the purposes of illustration, we need to be able to simulate passage or failure of individual components, and we're going to keep that extremely simple so that we can focus on the logic and behavior of the UrbanCode Deploy tool itself. So just so everybody's aware and knows what's going on behind the scenes, I have created a couple of very basic shell scripts, and the purposes of these scripts are to simply, as their names imply, fail or pass, depending on which one is called from the UrbanCode tool. So, as I said, I'll show you very quickly. The scripts, they literally, the fail script simply returns a 1 and the pass script simply returns a 0, so that we get a consistent and predictable result. Don't have to worry about what the plugins are doing, and can just look at the logic. So with that, we will jump into the UrbanCode tool and start looking at the behaviors. Okay, so looking at the IBM UrbanCode Deploy tool, what we're going to do is create what's known in the tool as a generic process. This is simply a process that is unattached to the deployment of a component. It's a generic process, could be used for anything, maintenance or otherwise, in the environment. So we're going to go ahead to the Processes tab, create new processes. Give it a nice generic name here, and take a quick look at the generic capabilities here. So we want to wire in, just to make sure everything's working the way we expect. We're going to put in a simple pass example, running the pass shell script that we looked at, and tell what directory to find the script in, save it, wire in this step, and so we should have a very simple flow. Should just run. We'll run our little local agent. Little one-step project should pass, run right through, and exactly as we had hoped. Alrighty, so coming back into our example process here, let's go in and change things up to the obvious counter argument and switch this from pass to fail. This time, of course, when we run this, we're going to get a very different result. Missed my click there, so we're just going to go in the other path here. And when this runs, we would of course expect the process to run and fail the step and of course the total job. So pretty basic. If the flow down the line passes, the job passes. If the flow fails, the flow fails. Of course, that's sort of simplistic thing that you would expect, and is great, except that in the real world we deal with complexities, logic, and a whole bunch of other things, and that's what we're really here to look at. So with this groundwork laid, we're going to go and start adding some complexity to the equation. Of course, the logical construct we've put here, we knew it was going to fail, and the job is set up that only passage will lead to a successful finish of the job. And that's done in these downstream lines, so where we see this little green checkbox. So when we have a component and then the line following it, and it has one of these status indicators on it, it determines how the overall job will progress given the outcome of this particular component. So in this scenario, we're saying run this step. If this step passes, go on to finish, and that is an if and only if statement. If it passes, go on to finish. Of course, we've hardwired this to fail, so we can illustrate what a failure looks like. That's great. But if we were to change this semantic to the little red bar, and which says on failure, so if this step fails, then proceed the job. If this step passes, it actually has nowhere to go. So it would actually fail the job. It's sort of a reverse logic kind of a thing. So now that we've set it to on fail, go to finish, that's great. Let's fire it off real quick, and we can see the power of reverse thinking. And so here we have a situation where even though this step failed, that's okay, because we said when it fails, go on to finish, and that's a successful outcome of that particular option. So if you're testing for, if you're running a test that it's successful when it fails, in other words, you want to make sure something's not there, this is a great and easy logical construct for doing that. There's a third setting, which is simply a gray dot, and the gray dot means you don't care whether it passes or it fails. Always go to the next step. So the statement here is simply that. No matter what happens out of this component, whether it's successful or not, I'm always going to continue on to the next step. And in this case, that will get us the exact same result as when we explicitly look for the expected failure. Alrighty, so that's kind of interesting. And these simple semantics allow us to create a reasonably sophisticated chain of events as we run and define our processes. Okay, looking at a more sophisticated version of the process, we've added a number of steps and added a concept of parallelism to the execution of the steps. So let's walk through and see what the construct we've put together here is and what some of the logical implications of that are. Up at the top here, we've added two steps in parallel. So we start the process, and the process will actually run these two steps, pass 1 and pass 2, at the same time in parallel onto the system. Then the process, once pass 1 and pass 2 are completed, then it runs pass 3 and on to the finish. Now, looking at the semantics that we've implemented here with our follow-on lines, we say that we've indicated that pass 1, the component pass 1 has to succeed, and the component pass 2 has to succeed. It's important to understand when executing this kind of a process that both of the conditions defined by the lines here must be met before this component pass 3 will run. So in other words, pass 1 must complete successfully, it must pass. Pass 2 must complete successfully, it must pass. Then and only then will pass 3 be executed. If either pass 1 or pass 2 does not evaluate as this line expects, pass 3 will never run. So we'll do a quick illustration of that, and just to run it. And so what we should see as the job kicks off is we should see pass 1 and pass 2 running at the same time, and we do. And when they complete, we should see pass 3 execute, and it of course will pass, and then the job as a whole will pass. So that's a very simple example of parallelism and the logic that's implicit in these line semantics. If I were to invalidate one of these conditions, say by turning this, or say that if I ran this job and this particular step failed instead of passed, we would see the behavior that I was discussing, and the job will not proceed to this third step and will in fact fail overall. Right, so that's the quick illustration of the difference in behavior there and what those lines end up meaning in terms of the job flow. So far we've seen a number of mechanisms that allow you to create sophisticated process flows in the UrbanCode Deploy tool. And that's all very good. It allows you to take those building blocks and build some useful things, but it would be remiss to not at least take a second and warn that you can get into trouble with these things, right? With great power comes great responsibility, or in this particular case, the opportunity to put things into an infinite loop. So, for example, here, in this scenario, the project starts out. It does our parallel run of a pass and a fail step, and when the fail step is set up so that if it succeeds, it runs out to the finish, and that's actually the only pass through to the finish, right? So we have when the pass passes and the fail passes, you can get to the finish. Okay, great. Well, the fail is also set up with a scenario of maybe retry, right? So one thing that's tempting to do is to add a corrective component to your flow. So if this fails, go run this other process, clean it up, and then we'll take another run back through the process, right? That would be this path here. So should this component fail, we're going to clean it up and we're going to try again. Sounds good on paper. Unfortunately, the problem with this is that if this is failing for good reason and is not easily correctable, there's not necessarily a path back out of this. So if we'll just go ahead and run this, and I'll show you what I mean. So as the project starts up, as we would expect, the two parallel steps, the pass and the fail run. The fail fails and starts down this other process of passing and cycling back through the process, but it can never get back to good, or back to a path to the finish, and so this job will actually just sit here and run in the system indefinitely, which is of course not good. So we're going to jump back over here and cancel it so that we don't have that going on. But it's important to understand what's happening there and how things operate. Not that that's going to be a common scenario, but it is a pitfall to overuse the logic, to over-automate things. Sometimes when things break, it's best to have somebody look at them before you try and have them auto-correct. Alrighty, so we've learned some techniques for sophisticated process flow, heard a little bit of a cautionary tale, and that's a pretty good set of tools for this video edition. Thank you for watching today's video. This video was provided by the Avnet Services DevOps practice team as part of our ongoing effort to further the education of the community and broaden the community's knowledge in general. We're available at any of the social media links listed here on this card. My contact information is down below. Again, my name is Dan Zenkroff. I'm the DevOps practice lead for the Avnet Services DevOps team. Thanks, and have a good day.